Good day to everyone listening or watching this video tutorial. I am Edelyn May M. Erocedo, first year civil engineering student currently studying at Eastern Visayas State University or MOOC campus. So today I will be discussing about three difficult topics. The first topic is the angle between two curves. The second topic is finding the maxima and minima. And the third topic is about the equation of normal and tangent line of a curve. So our first topic is all about angle between two curves. So in the book, it says that the angle between two curves at the point of intersection is defined as the acute angle between their tangents at the point of tangency. So basically, this angle between two curves just means acute angle between two curves. So in order to find the acute angle between two curves, we will use the formula, which is tangent of theta is equal to the absolute value of the second slope minus the first slope over 1 plus the product of the second slope and the first slope. So in finding the angle between two curves, we have four different steps. So step 1, we have find the intersection points. The second step is to use the first derivative. The third step is to find the slope. And the last step is using the formula, which is this one. We will use this one. So I have an example here. So the example states that find the angle between two curves of these following functions. X squared y plus 3y equals 16 and x squared y equals 4. So the first step we are going to do is to find the intersection point. And what we mean about finding the intersection point is about finding the values of x and y. So x squared y plus 3y equals 16 and x squared y equals to 4. So we will get the values of x and y. So in this second equation, it states x squared y is equal to 4. And in the first equation, there is x squared y. So let's just substitute the value of x squared y here in this equation. So 4 plus 3y equals 16. So now we will get the value of y. It makes us easier to find the value of y. So 3y equals 16. And the constant number 4, we will transpose it to the other side. So the positive 4 becomes negative 4. So 3y is equal to 16 minus 4 is equals to 12. Divided by 3, both sides, in order to get the value of y. So this is cancel. Y is equal to 4. So we have now the value of y, which is 4. So by using the value of y, let us now look for the value of x. So let's use the second equation. So x squared y is equal to 4. Since our value of y is equal to 4, so x squared times 4 equals 4. So x squared times 4, it becomes 4x squared equals 4. Divided by 4, cancel. X squared is equal to 1. Since 4 divided by 4 is equal to 1. Since there is an exponent of 2, we will use the square root in order to get rid of the exponent 2. So this is cancelled. X is equal to the square root of 1 is just 1. So our intersection points of this function is 1 and 4. So we are now done in step 1. So let's proceed to the step 2. So now we are in the step 2, which is using the first derivative of these two functions. So, x squared y plus 3y equals 16. This is an example of implicit differentiation. So, at So, let's differentiate the first term, the second term, and the third term. So, x squared y. So, we will use the product rule. So, the product rule, it states that u times the derivative of v plus v times the derivative of u. So, in this term, this is u. X squared is u and y is v. So, u is equal to x squared. The derivative of du is 2x. 2x. Next, v is the y. And the derivative of v is, since y, the derivative of y is y prime. So now, let's use the uv plus dv rule. So, u, which is x squared, times the derivative of v, which is y prime, plus v, which is y, times the derivative of u, which is 2x. So we are now done differentiating the first term. So now let's differentiate the second term, which is 3y plus 3. The derivative of y is y prime equals. The derivative of 16 is 0, since 16 is a constant number. So, the derivative of constant is always 0. So, we will write 0 there. So, this becomes x squared y prime plus 2xy plus 3y prime is equal to 0. So, combination of like terms, we will combine x squared y prime plus 3y prime y because they have both y prime. And this positive 2xy, we will transpose it to the other side. So, this becomes negative 2xy. So, next, we will factor out this term. So, this becomes, the common factor is y prime. Y prime divided by x squared y prime, this becomes x squared. Plus y prime divided by 3y prime, so this becomes 3. Div 2xy. So we want to get the y prime. So in order to do that, we will divide it both sides by x squared plus 3. X squared plus 3. This is cancel. Y prime is equal to negative 2xy over x squared plus 3. So this is the step 2. We are done with the step 2. So now we are going to do the step 3. So we are now solving for the slopes. So we are going to solve for the slopes of the equation 1. The equation 2, we will discuss it later. So since we have the point of intersection, which is x equal to 1 and y is equal to 4, so we will just substitute the value of x and y to this the equation. So y prime is equal to negative 2 times the value of x, which is 1, times the value of y, which is 4, over the value of x is 1 raised to 2 plus 3. So negative 2 times 1 is negative 2. Times 4, it becomes negative 8 over 1 squared is just equal to 1 plus 3 is equal to 4. So negative 8 divided by 4, the answer is just negative 2. So since y prime is equal to the slope, so the slope 1 is equal to negative 2. This is our slope for the slope 1, the equation 1. So now let's go to finding the slope of the second equation, which is this one. So now we will derive this equation. So this is also an example of implicit differentiation. So as we said earlier, this becomes, we will use the product rule. So this becomes x squared y prime plus 2xy. Since this 2xy came from y times 2x. The derivative of this is x squared y prime plus 2xy equals the derivative of a constant number 4 is just 0. So, this 2xy, we will transpose it to the other side. So, x squared y prime is equal to negative 2xy. So, since we want to remain the y prime here, we will divide it by x squared. X squared. So, this is cancel. Y prime is now equal to negative 2y over x. Why 2y over x? This is because the variable x here has an exponent of 1. So, we just minus the 2 and 1 exponent. So, this will become 1 here. So, that is why y prime is equal to negative 2y over x. So, now we will solve for the slope of equation 2. So, we have the point of intersection, which is 1 and 4. So, we will just substitute the value of x and y to this equation. So, negative 2 times the value of y, which is 4, over the value of x, which is 1. So, y prime is equal to negative 2 times 4, which is negative 8 over 1. So, y prime is equal to negative 8. So, since y prime is equal to the slope of the second equation, so this means the slope of the second equation is equal to negative 8. So, we are done with the step 3. So, now let's proceed to the step 4, which will use the formula in getting the angle between two curves. So now, we will use the formula in getting the angle between two curves. The formula, it states that tangent of theta is equal to the absolute value of m2, or the slope 2, minus the first slope over 1 plus the second slope times the first slope. So we already have the value of the first slope and the second slope. So what are we going to do is just to substitute the values. So tan theta is equal to absolute value of m2, which is negative 8, minus m1, negative 2, over 1 plus m2, which is negative 8, times m1, which is negative 2. So, we will use the calculator in order to get the value. So we will input the value here in the calculator. So negative 8 minus negative 2, 1 plus negative 8. So we have tan of theta is equal to negative 6 over 17. Since we are talking about the absolute value, so this will become tan theta equals 6 over 17. Now, we will get the angle. So we are talking about the angle. So we will remain the theta here, and this tan, it will become tan raised to 1, or what they call arctan, the inverse. So arctan of 6 over 17. So if we are not using the calculator, this could be the final answer. But if we need to get the value of the angle by using the calculator, so we will input here, shift, tan. We will input the value, which is 6 over 17. This will give us the answer of 19.44 degrees. Not in radian. Take note, this should be in degrees, not in radian. So the angle between the two curves, this one, the angle between them is 19.44 degrees. This is our final answer. So I have here another examples in finding the angle between two curves. So we have x squared plus y squared equals 5x and y squared equals 2x. So as what we discussed earlier, the first step is to find the intersection points, or should we say solve for the intersection points. So we have x squared plus y squared equals 5x and y squared equals 2x. So we already have the value of y squared, which is 2x. So let's just substitute the value of y squared in order for us to find the x easier. So let's substitute x squared plus the value of y squared, which is 2x, equals 5x. Let's divide both sides by x because they have common variable, which is x. So this becomes x plus 2 equals 5. So this will become easier for us to find the value of x. So we will transpose the constant number 2 here. So x equals 5. Thus positive 2 becomes negative 2. So x is equal to 3. So we now have the value of x, which is 3. So now, let's solve for the value of y. So y squared, by substituting the value of x, equals 2 times 3. So y squared is equal to 6. So in order to get rid of the exponent 2, we will just use the square root. This is cancelled. So y is equal to the positive or negative value of the square root of 6. So our point of intersection is 3 and the positive and negative value of square root of 6. So this is our PI, which is the point of intersection. Now we are done with the step 1. So now let's go to the step 2. So step 2, we will get the first derivative of these two equations in order to get the slope. So step 2, have x squared plus y squared is equal to 5x. This is the equation 1. We will solve for the first derivative of this. So this is an implicit differentiation. So this x squared, this becomes 2x plus 2y, the derivative of y is just y prime, equal to 5x. So 5x, no, this is just 5 times the derivative of x is 1, so this becomes 5. So this is it, the first derivation of our equation 1. So we have the point of intersection, which is 3, and positive and negative value of square root of 6. So we will just substitute. So, to 2 times the value of x, which is 3, plus 2 times the value of positive negative square root of 6. Y prime equal to 5. So 6 plus 2. So 2. We will transpose the constant number 6 to the other side. So negative 1. So we need to have only y prime here. So what are we going to do is we will just divide both sides by 2 times the positive or negative value of the square root of 6. This is cancelled. So y prime is equal to negative 1 over 2 is the value of 6. So this is our slope 1. Slope 1 is just negative 1 over 2, so negative square root of 6. But if we will use the calculator to get the exact value of this, so m1 this is just negative 0.204. So now we will get the slope of the second equation. We will try to differentiate it first and then we will get the slope. So now let's differentiate the second equation. So y squared is equal to 2x. Another example of implicit differentiation. So this will become 2y, y prime is equal to 2 since the derivation of x is just 1. So this will become 2 divided by 2y by 2y. This is cancelled. Y prime is equal to, this is cancelled also. So this becomes 1 over y. So we have the value of point of intersection, which is 3, and positive and negative value of square root of 6. This is our point of intersection. So we will just substitute the value of this to this. So we will not be needing we will not need 3. So we will just need the value of y, which is this one. Y prime is equal to, this will become slope 2 is equal to 1 over y, or 1 over positive or negative square root of 6. So this is our m2. So if we want to get the exact value of this m2 or the slope 2, we will use the calculator. So 1 over square root of 6. Answer is 0.408. So this is the value of our second slope. So we already have the first slope and the second slope, so we can proceed to finding the angle between two curves, which is the last step. So now, as what we discussed earlier, we will find the angle between two curves. So we will use the formula tan theta is equal to the absolute value of the second slope minus the first slope over 1 plus the product of the second slope and the first slope. So we already have the value of the first slope, which is 0.204, negative. This is negative 0.204. And the second slope is 0.408. We will just substitute the value of this to this formula in order to get the angle between two curves. So, tan theta is equal to m2, which is 0.408 minus 0.204 for 1 plus 0.408 negative 0.204. So now, we will use the calculator. Tan theta is equal to, we'll use the calculator, this one. So, this will give us the answer of 0.667. 0.667. Or, since in the calculator it states that 0.6675, we can just round it up. Becomes 0.668. And now, we'll transpose the tan here. So this becomes the tangent here. This becomes arctan of 0.668. This could be the answer. This would be the final answer. But if we want to get the exact amount, the exact value, I mean, so theta is equal to, we will use the calculator in this one. Answer is 33.74. So 33.74 degrees. So this is now our final answer. So the value of the angle between these two curves is 33.74 degrees. So this is all about the topic 1, angle between two curves. So let's recall everything. So step 1, all we need to do is to find the point of intersection, the PI, or solve, find or solve. Let's put it that way, find or solve the point of intersection. And once we get done with the step 1, and we are done getting the point of intersection, we will now proceed to step 2, which is finding the first derivative of the equations, of both the equations or curves, in order to get the slope. So we will put it here, step 2, find the first derivative. And once we are done with the step 2, we will proceed to step 3, which is solve for the slopes, or finding the slopes. We are solving for slopes. So after we find the slopes, we have the two slopes here. We can now proceed to the step 4, in which we can use the formula. This formula, I mean. And use this formula. So use the formula. So finding the angle between two curves is very easy. If you are familiar with the derivation, if you are familiar with the principles of algebra, yes, so if you are familiar with that, this topic is just an easy peasy lemon squeezy for you. So we are done with the topic 1, and I hope you have learned something in this video tutorial, because I will also be discussing about our next topic. So just don't forget the 4 steps in finding the angle between two curves. First, find the point of intersection. Second, find the first derivative or solve for the first derivative. The third step is to solve for the slopes. And the fourth step is use the formula, which is this one. So that's all. And let's proceed to the second topic. We are done with our first topic. So now let's go to the topic 2, which is the maxima and minima. So when we say maxima and minima, it came from the word, maxima came from the word maximum, and minima came from the word minimum. So maximum, minimum, and inflection point. So this topic is all about maximum, minimum, and inflection points. So consider the graph of the curve whose equation is y equals f of x as shown next page. So this page. So points B and D are the highest and lowest points respectively. So as we can see on this graph, we have point B, and point D. So on the curve, considering their immediate neighboring points. So these 2 points are called the critical points. So this point B and point D are called critical points. So at critical points, the slope is 0 because if we draw tangents through these points, the tangents are horizontal. So the slope is 0. So the tangents are horizontal. So as you can see in the graph, the tangents are horizontal, not vertical. So now let's consider point B. Point B, its abscissa is x equals b. Before point B, x is less than b. So the tangents land to the right, which means that the slope of the curve there is positive. After point B, x is greater than b. So the tangents land to the left, which means that the slope of the curve there is negative. So a critical point having this characteristic is called a maximum point. So now let's consider point D. Its abscissa is x equals d. Before point D, x is less than d. So the tangents land to the left, which means that the slope of the curve there is negative. So you can see at the graph, after point D, x is greater than d. So the tangents land to the right, which means that the slope of the curve there is positive. So a critical point having this characteristic is called a minimum point. So we have there. We understand now what is maxima and what is minima. So don't worry. I will give a table for this as a summary. So in order for you to understand. So I have here the summary of what I've read earlier. So in order for us to understand it better, so at first derivative test, we have first derivative test and second derivative test. So at maximum point, we can tell that the point is at its maximum if before the point, the y prime is greater than 0. And after the point, it becomes the y prime is less than 0. So the transition or the rate of change from being positive to negative. So that is maximum point. So at minimum point, before the point, y prime is less than 0. And after the point, becomes y prime greater than 0. So the rate of negative, so the transition of being negative to positive, we can tell that that point is at its minimum at the first derivative test. So in the book, it says, now let's study the significance of the second derivative. We are going to find the second derivative. So the first derivative is the slope of the curve. So the importance of the first derivative is to get the slope of the curve. So the second derivative, denoted by this, is therefore the rate of change of the slope. So the rate of change. So there is point of inflection. There is a point of inflection in the second derivative test. So at its maximum point, the y2 prime is greater than 0. or it is negative. At minimum point, y2 prime is greater than 0 or means positive. So, I will give an example of this so you are able to understand fully what is maxima and minima in the application of derivatives. I have here an example in finding the maxima and minima. So in this example, it states given y is equal to x cubed minus 3x squared minus 9x plus 10. Find the maximum point, the minimum point, and the point of inflection. So first, we will use the FDT. What does FDT stands for? It stands for first derivative test. So, y equals x cubed minus 3x squared minus 9x plus 10. We will get the first derivative of this. So, y prime is equal to 3x squared. We will just put the 3 here. And 3 minus 1 is equal to 2. Minus 6x. 3 times 2 equals x. 2 minus 1 is equal to 1. Minus 9 times the derivation of x is just 1. So 9 times 1 equals 9. This is 0. So it is unnecessary to put 0 in this equation. So we are as y prime is equal to 0, as our function is equate to 0, so let's equate this to 0. So 3x squared minus 6x minus 9 is equal to 0. So what is common among these three? So the common of here is 3. So let's divide it by 3. So this becomes x squared minus 2x minus 3 is equal to 0. So now, we can find the value of x in this equation. So 0 x x. So this is 3 plus 1. So this becomes 3 0 x plus 1 is equal to 0. So we can now easily get the value of x. So x is equal to positive 3 and the other x is equal to negative 1. So the value of x the first value of x is 3. So we will use that value and substitute it to the original equation. So y is equal to 3 times 3 squared minus 9 plus 10. So this becomes y is equal to negative 17. 3 times 3 times 3 is equal to 27. 3 times 3 is 9. Raised to 2. This is 9 times 9 equals 81 minus 9 times 3, 27 plus 10. So this becomes negative 17. So we have now the first critical point, 3 and negative 17. So the rate of change from positive to negative, so this critical point is called the maximum point. And next, we will use the other value of x, which is negative 1. So we will substitute the value of this value of x to the original equation. So y is equal to negative 1 cubed 3 So the answer is just positive 15. So our second critical point is at negative 1 and 15. And as you can see, the transition of points from being negative to positive, this means that this critical point is called the minimum point. So, in order for us to easily recognize or classify that this certain point is maximum or minimum, you just look at the value of x. If it is positive, so it means it is at its maximum. And if it is negative, it is at its minimum. That's the only thing you just need to familiarize or memorize. So now, we are done with the first derivative test. So we are able to identify the maximum point and the minimum point with these two critical points. So now, let's go to the second derivative test in order for us to get the point of inflection. So now we will use the SDT or the second derivative test in order for us to get the point of inflection. So using the original formula, y is equal to x cubed minus 3x squared minus 9x plus 10. The first derivative is 3x squared minus 6x minus 9. So since we are talking about second derivative test, we will get the second derivative of this equation. So become 3 times 2, this becomes 6x minus 6 times 1, this becomes 6. So this is now our second derivative equation. So as I've discussed earlier, y must be equate to 0. So we will just equate this equation to 0. So 6x is equal 6x minus 6 is equal to 0. So what is common among them? It is 6. So we'll divide this by 6. So this becomes x minus 1 plus 0. So we get the value of x. So x is equal to positive 1. So we will use the value of x in order to find the value of y. So if we complete the value of x and y, that is already called the point of inflection. So at x is equal to 1. So we will use the original equation. So this is x cubed minus 3x squared minus 9x plus 10. So we will just substitute. This becomes 1 raised to 3. So the value of y is equal to negative 1. So therefore, our point of inflection is at Pi, or point of inflection, Pi is at point 1 and negative 1. So this is it. This is the second derivative test. We are able to get the maximum point and the minimum point by using the FDT. And now we are able to get the point of inflection by using the SDT. So just to remember, in finding the FDT, in finding the maximum point and minimum point, use FDT or the first derivative test and find the values of x and y in order to get the critical points, thus classifying the maximum point and the minimum point. So this is all about the topic 2, maxima and minima. I hope you learned something from this topic, um, you just need to remember what I've discussed earlier. So let's proceed to topic 3. So now let's go to topic 3. Our topic 3 is all about the equation of normal and tangent line of a curve. So in order to get the equation of normal and tangent line, we have 3 steps. The first one is derivation, the second one is slope, and the third one is the equation. So, but before that, we'll have to be familiar with the tangent formula and the normal formula. So, the slope of the tangent is just equal to the value of is equal to the sum of the equation, and the slope of the normal is -1 over the slope of the tangent. Why? Because normal has the slope negative reciprocal to the tangent, because its slope has the negative reciprocal to the tangents. That is why -1 over m. So the formula of the equation of the tangent and normal, the tangent is y minus y sub 1 equals m for the slope of the tangent times the quantity of x minus x sub 1. And the formula for the normal equation is just y minus y sub 1 equals the slope of the normal line times the quantity of x minus x sub 1. So let's just remember this formula, remember the slope in order to get the tangent and normal line of a curve. I mean the equation of normal and tangent line of a curve. So I will give you 2 examples in order for you to understand fully how to get the equation of normal and tangent line of a curve. So, for example, x squared minus y squared is equal to 9 at point 5 and 4. So, as we discussed earlier, step 1 is derivation. We'll get the first derivation of this equation. So, x squared minus y squared is equal to 9. This becomes 2x minus 2y y prime is equal to 0. So, we need to get the y prime. So, we'll divide this by negative 2y. Now, first, let's just transpose this term. So, negative 2y y prime was negative 2x. And then, we divide it by negative 2y in order to get the y prime. 2y y prime is equal to positive x over y. So, since our point is at 5 and 4, this is x, and this is y, so we will just substitute. So, the first slope is equal to the value of x is 5 and the value of y is 4. So, the slope of the tangent is 5 over 4. So, we are now done in getting the slope of the tangent. Now, let's go to the finding the equation of the tangent line. So, using the formula y minus y sub 1 equals m, or slope of the tangent, times the quantity of x minus x sub 1, we will use that formula. So, we will substitute these points and this slope. So, y minus y sub 1 is 4 equals the slope is 5 over 4 times the quantity of x minus x sub 1, which is 5. So let's multiply both sides by 4 in order to cancel the denominator 4. This is cancel. So 4y minus 16 equals 5x. 5 times x equals 5x times 5 plus minus 5 times 5 is equal to 25. Let's equate this to 0 for y minus 16 or 5x minus 16 plus 25 is equal to 0. For y minus 5x, negative 16 plus 25, the answer is 9, positive 9. So this is now our equation of the tangent line. This is the tangent equation. By being able to find the slope of the tangent, we are able to find the equation of the tangent easier. So, do you understand now? So now let's go to finding the normal line by using also this equation. So since we are done finding the tangent equation rather, of this equation, we are now going to find the normal equation of this equation. So the first step is derivation. So derivation. We are done with the derivation earlier. So the slope of the tangent is 5 over 4. So earlier we discussed that the slope of the normal is just the negative reciprocal of the tangent. So this will become negative 1 over m, or negative 1 over 5 over 4, or 5 over 4. So this is the normal slope, or slope of the normal line. Now, let's find the equation of the normal line by using this slope. So, y minus y sub 1 equals the slope of the normal line times the quantity of x minus x sub 1. We will use this point. Y minus y sub 1, this y, this is x, 4, 2. This is negative 5 over 4. Negative 5 over 4 times x minus 5. So again, in order to get rid of the denominator 4, we will just multiply this by 4. Let's cancel. 4. 4y minus 16 equals negative 5 times x, it becomes negative 5x. Negative 5 times negative 5, it becomes positive 25. Transpose this equation to the other side and equate it to 0. So this becomes 4y plus 5x minus 16 minus 25 equals 0. So our normal line is 4y plus 5x. Negative 16 minus 25 is negative 41 equals 0. So this is now our equation of the normal line. So this is very easy to find the equation of the normal line, since the slope is already given by the tangent, and it states that the slope of the normal line is just the negative reciprocal to the tangent. So we will just put the slope of the tangent here. So we are able to get negative 5 over 4. Now, substitute all the values of x and y and the slope in this formula in order to get the equation of the normal line. So I know this is not just enough for you, so I will be providing another example of this. So in order for you to fully understand how to get the equation of normal and tangent line of a curve. So let's go to the second example. So we have x cubed minus xy plus y squared equal to 8 at point 2 and 0. This is x, this is y. So this is an example of an implicit differentiation. So the first step we're going to do is to differentiate or derivation. So we will get first the tangent equation or the tangent line. So this becomes 3x cubed, 3x squared rather, minus x. This is, we will use the product rule in this one. Xy prime plus y plus 2yy prime is equal to 0 since the derivative of a constant is 0. And after that, we will combine like terms. We will combine like terms with y prime. So 2yy prime minus x y prime is equal to transpose this 2 on the other side, 3x squared, negative 3x squared minus y. So what is common here on the left side is y prime. So let's factor. 2y prime divided by y prime is just 2y. xy prime minus xy prime divided by y prime is equal to x. It's negative 3x squared minus y. So in order to get y prime, we will divide both sides by 2y minus x. Cancel. Y prime is now equal to negative 3x squared minus y over 2y x. So now, we will get, second step, we will get the slope by substituting the value of this. So, y prime is equal to negative 3 times 2, the value of x is 2 squared minus 0 or 2, 0 over I mean 2 minus 2. So the answer is 6. So the slope of our tangent is equal to 6. So now let's get to the equation. Y minus y sub 1 equals the slope of the tangent times the quantity of x minus x sub 1. We have the slope of the tangent, we have the points, so we will just substitute the following values. So y minus 0, once the slope is 6, is x minus x sub 1 is 2. So y is equal to 6x minus 12. Y transpose and equate it to 0. 6x plus 12 is equal to 0. This can be the final answer, or this could be the final answer. This is the general form, and this is the y-intercept form. So now, we are able to get the tangent equation of this function. So now, let's find the normal equation and the slope. given earlier that our slope of the tangent is equal to 6. So the normal slope, the slope of the normal equation is just the negative reciprocal. So negative 1 over 6. Now, we'll we'll solve for the equation of the normal line. By using the formula y minus y sub 1 equals the slope of the normal line, normal equation, is x minus x sub 1. Y minus 0, negative 1 over 6, x minus 2. So, just like earlier, we'll just multiply it by 6 in order to get rid of the denominator 6. 6y plus negative x plus 2. So, 6y plus x minus 2 is equal to 0. So, this is the equation of the normal. But, if the instructor said to simplify, we will divide this 6y plus x minus 2 0 to 6 in order to have one numerical coefficient of this variable y. So this becomes y plus x over 6 minus 2 over 6 equal to 0. This is the general form of the simplified normal equation. It depends on the instruction. So it could be this or it could be that. You choose. It depends on the instruction. So that's all about the topic 3, and I hope you learned something about my discussion. I am struggling in speaking English, so I hope you understand. But I'm trying my best to speak in English as fluent as I can. So that would be all. That ends my topic, and I'll see you on the next video tutorial. Before this video ends, I just want to extend my heartfelt gratitude to our instructor of this subject, because he gave us the opportunity um, to learn more by studying on our own pace, on our own studying technique. Thank you, sir, for giving us this opportunity rather. Thank you for the another chance, and I hope you had good day. And that's it. Thank you, sir. Thank you so much.